All right, greetings guys. We're about to do something called simplifying complex rational expressions. It sounds horrible, but complex rational expressions, all that means is you have fractions inside of the fraction. I call these double fractions. So there's two types of double fractions. If it's type 1, you're going to see 3 or less fraction bars. If it's type 2, you're going to see 4 or more fraction bars. That's the big difference between the two. So I'm going to go through type 1, then I'm going to go through type 2, then we'll get some practice in on this concept. So let's look at type 1. So here we go. Type 1 looks like, well, like this guy right here. Now, this is not something I'm going to put on your test. It's not, because it's too easy. But it still looks weird. But what I'm trying to say is I see 1, 2, 3 fraction bars. And that's what makes this a type 1. So, how do we handle this situation? Well, fraction bars in this, that's just code for divide. That's all that really means. So this is technically 2/3 divided by 4/5. And if it was 2/3 divided by 4/5, well, you could punch it into your calculator, but definitely no matter what mode you would be in, Math Print or Classic, you would have to put these in parentheses if you were going to punch it into your calculator so that it actually gives you the correct solution. See, calculators get confused when there's too many things to divide. But back in the 4th grade, they said, flip the second fraction and turn it into a multiply. That's what they told us. 2/3 times 5/4. And then if you want, you can just multiply straight across, and you would get 10/12. Or they taught us this trick, hey, you could do a little bit of pre-reducing. You could cross-cancel things, and you'd get 5/6, which is technically the same thing as 10/12. It's just in reduced form. Now, the thing is, they've taught us this since 4th grade. Flip the second fraction and multiply. Well, I'm guilty of this too, where I just tell you how to do something and I don't explain why it works, but here's the underlying concept. Why do we flip the second fraction and not the first one? Well, here, I'm going to get rid of these highlighters. Here. I'm going to get rid of this so I can have some room here. But what they mean is if I took the bottom of this fraction and multiplied it by 5/4, that would all cancel out and I'd get 1 on the bottom. But you can't multiply the bottom of a fraction without multiplying the top of a fraction. You have to do the same thing to the top and the bottom. And that's why in the 4th grade they told you if you see division, you can rewrite it as a flipped multiply. Because you'll see in the bottom here, I'd get 1. In the top, I'd get, well, 5/6. 5/6 divided by 1 is still 5/6. So type 1 problems have this look to them. And the trick with them, rewrite them so they look like a division question. How many fraction bars do you see? And you say, well, I see 1, 2, 3 fraction bars. So as soon as you count 3 or less, you would rewrite this thing. You would rewrite it so that it says 10/x divided by 5/x cubed. And then, well, let's just do what they told us in the 4th grade. Let's flip and multiply. And if I flip this over and multiply, just like I did in my very first example, I can do some pre-reducing. I can cross-cancel if I want. 5 goes into itself once. 5 goes into that twice. And then I go, hey, I have an x to the first in the bottom, x to the third in the top. So these guys I can say, hey, who's more powerful, top or bottom? And I'd say, hey, it's the top one. So I can simplify this so that there are no longer double fractions in my problem. To simplify a complex rational expression, remember that just means double fraction. To simplify it, if it's type 1, rewrite it like a division, and then do what you've done since the beginning of time. Try to cross-cancel some stuff, organize your information, and you get a nice, simplified answer. Let's play again. Let's look at another one. But all of these first ones are all going to be type 1 problems. I see 3 fraction bars. That makes it type 1. And as soon as I see 3 fraction bars, I would rewrite it. And I'd say, okay, this is 4x over x squared minus 9, which I'm hoping you recognize that thing. That guy is the difference of squares. But I'm going to say divided by 8x over 2x plus 6. Well, if you want to cut out the middle step, which is right here, this is the middle step. If you want to go, you know what? Can I just rewrite this thing so it looks like this right off the bat, where I already flip it in my mind? And the answer is sure, I don't care. You could do that. You don't have to write this step out if you don't want to. But for, I'm trying to go through every step so I don't lose anybody, so I'm showing all the work. Then down below here, like I said, this guy is just difference of squares. I go, hey, I know you, x plus 3, x minus 3. And then, hey, in the top part here, I have a GCF. I could take out a 2, and I could do x plus 3 to get that to factor up. Because when you are dealing with a double fraction, when you got a big old double fraction, your job is to make it look like it's not a double fraction. And this is how we do it. So I'm going to knock out this guy with this guy, of course. And I could go, you know what? 4 goes into 8 twice. And this x can knock out this x, because single letters knock out single letters. And then, wait a minute, I got a 2 in the top. I got a 2 in the bottom. They could cancel even. What the heck? It looks like everything in the top is gone. I don't put 0 up there, though. I put a 1 to hold the place. And then it looks like the only other thing that made it through here, I couldn't find a match for that to get rid of it. And that's my answer. So mathematically, what I'm showing you guys is something called a type 1 style double fraction. And what do? We rewrite it using division idea, and then we reduce it, which in this case means factor and cancel. This is a much simpler version of this original problem. Simplify rational expressions. So here we go. Let's look at this one because it looks way worse. But you know what? You've done this. I am going to write out all my steps, but if you don't want to write this step right here, if you do not want to write it out like this, here's the top fraction divided by the bottom fraction. If you don't want to write out this step here, you don't have to. I'm not going to hold it against you. But I do want to see this move. I want to see this move where you show me that this times this, yeah, this part I want to see at least, so I have something to grade. So if you're doing this on the test, which by the way you'll see something like this on the test, you will, show me your work. Remember, you get more points out of me if I can trace all your steps. So here we go. I'm going to look at this and say, I can't do anything here. There's nothing I can do with that thing. But I do see a GCF somewhere in this problem. The GCF happens to be in the top right part. And I go, look, I can take out a 6, and then bam, there's my dude. There's my guy. I already have a match. Now I got to break up these guys. Well, I showed you a trick on the graphing calculator. If you're still timid about trying to factor something, you can use the calculator to help you see that this part right here could factor. And then heck, down here, I'm going to guess that it's probably not 1 times 30 that I need. It's probably not 2 times 15 to get 30. No, I'm going to assume it's probably going to have one of these in it. Or maybe not. Looks like that's the right way to go. So be careful, because sometimes when you're trying to simplify something, you jump the gun and you just assume it's going to work. Let's look. It looks like those are the only 2 things that happen to match exactly. So what do I do with all this junk? You keep track of it. There's a 6. I can't take this 6 right here and knock out this 6. I can't do that. One of them's a number. One of them's a binomial. So what happens? Well, oops, sorry. I forgot to change pens. Sometimes when you go to simplify these things, you get something that is still quite beefy. And this guy is a little bit beefy. But guess what? You're done. You can't take anything else out of that problem, but you definitely have something that is less complicated than what you started with. That's the whole point. You don't ever want to have a fraction inside of your fraction. It's horrible looking. This isn't much better, but it is complete. So here we go. Let's take a look at something that's type 2. Now, I wanted to start out with something that looks definitely like a type 2. There is 1, 2, 3, 4 fraction bars. So here is my warning. If you get stuck on something and you're trying to get help, that's what Photomath can be helpful for. It's true. Not during a test trying to sneak a question in on me, because this is where it's going to really show up. See, this guy right here, go back to type 1. Photomath does everything based on this trick I just showed you. Photomath will do this thing very bizarrely. What I'm about to show you is much easier than what Photomath will show you. And that's when I totally can tell if you just copied your answer off of a Photomath thing. Please don't do it for anything that's type 2. Let me show you the easiest way to do this, and then if you get stuck, ask for help. I'm in the Zoom room. You can ask for help. So, what do we do about this? Well, here's the thing that I know about fractions. I know that if I multiply the top part of a fraction and the bottom part of a fraction by the exact same thing, I'm technically not changing it. I multiply in this one. Here's what I'm going to do. I'm going to take the whole top part and the whole bottom part, and I'm going to multiply the top part by 2x. I'm going to multiply the bottom part by 2x. If I'm multiplying by 2x over 2x, that's the same thing as 1. 2x divided by 2x is 1. You can multiply anything by 1. It doesn't technically change it. But what it does do for us is it allows us to cancel out the double fraction look. So, let me explain here. If I were to multiply the bottom part by 2x, I could make it look like a fraction if I wanted to. You don't ever have to show that step to me because it actually looks worse on some of them. But guess what then? 2x cancels 2x. What's left over? 5. 5 is all that's left over in the bottom. If I multiply this by 2x, well, it's a binomial, so I have to distribute it. But if I multiply the top by 2x, in the first part, these guys cancel. What do I get left with? X times 1. Well, that's just x. Plus, if I multiplied this by this guy, what would cancel? The x would have taken out the x. I would have just been left with 2 times 3. That's 6. And that is how you simplify something that is type 2. How do you recognize type 2 problems? Count the number of fraction bars. 4 or more makes it a type 2. Okay. Now, the first time I show you this, you might go, let's practice a little more. Let's look at something similar but not the same. Well, this one only has 3 fraction bars in it. Okay, here's the deal. I could make this look like a fraction, and I could make this look like a fraction. Then you count it up. Then you say how many fraction bars, and I think you'll agree with me that there are 5 fraction bars, which is more than 4. Well, what do I do in this case? Well, hey, I didn't go through it in the last one, but what you're looking at is the denominators. I got a 4, I got a 1, I got a 5, I got another 1. What is the least common multiple? We call that the LCM. The least common multiple is the smallest number all the bottom stuff goes into. Well, that would be 20. 4 times 5 is 20. So I'm going to multiply the entire top part and the entire bottom part by the number 20. And please write in this step in your work. Do not make me guess. Write that in, because what I'm about to do is multiply this double fraction by 20 twentieths. If I multiply by 20 twentieths, let's do the top part first, then we'll do the bottom part. Well, 4 would go into 20 5 times. 5 times what's up here. Plus, let's do this one. 1 goes into 20, well, 20 times. So it'd be 20 times 3, that'd be 60. Let's clean this up. Let's make this as pretty as possible. In the top, I'm going to run out of room, so I'm going to go down below here. In the top, I would have 5x plus 5 plus 60. That's what I would have in the top, and I think you guys can see that I could just write that like that. And that would be the top part. Let's go through the bottom part. If I reduced here, 5 goes into 20 4 times. 4 times this. Minus, because there's a minus, 1 goes into 20 times, so 20 times 1, that's just good old 20. Once again, I'm running out of room, so I'm going to distribute this, and I'm going to call it 4x minus 8, minus 20 more, and I can put these two guys together now, and I could call it 4x minus 28. Now, that's a great answer. I like it. No problems for me. I'm going to give you full credit for this. But there are some books that will do this. They'll go, hey, guess what? There's a GCF in the top and the bottom. There's a GCF there. If you wanted to, you could pull the 5 out and then call this x plus 13. You could. I could pull the 4 out. You pull the 4 out, you'd get x minus 7. Here's the thing. Does that let you reduce anything? Can I take this and go, oh, they match? No, I can't do that. I can't. So here's the thing. Sometimes you get left with a fraction that could be written this way, which is totally correct, or the other way, which is also correct. So on my answer key, whenever this happens, you'll see I write the answer both ways, but it doesn't matter to me. It doesn't. If it doesn't help you reduce, you're okay. So I would say this big, ugly problem that we started with can look like this or like this. They're both correct. Now, let me back up 1 second. The LCM is the key to getting this right, and this is the thing PhotoMath does not do, so please be careful of PhotoMath. It can be very messy in this section. What did I multiply this one by? I multiplied it by 2x in the top and in the bottom. Why? Because I had an LCM. What do they all have in common? What is the least common multiple? 2x. That's why I did that. Let's use that strategy one more time. Let's practice. So the first one I did had 4 fraction bars in it, clearly written in. This one, I had to add some fraction bars to it to make it look right. And then I counted the bars and I went, there's 5 bars. So let's see, how many bars are in this one? Well, there's 3. But if I see a whole number, what I'm supposed to do is write it in like that, and then I count it. So I have 1, 2, 3, 4, 5 fraction bars in this problem, which makes it a type 2. Now this time, look at this guy in the bottom. He's an x minus 2. He's a binomial. Hey, I'm a binomial. So if you're going to try and get rid of a binomial, the only way to do it is multiply by a binomial. So all in the top. Now this time I'm going to use different colors. Whoops. Because I want to make sure any change I make in this one, I'm going to use a different color. So I'm going to take the whole top part. And I'm going to take the whole bottom part. And I'm going to multiply by the LCM, which in this case turns out to be x minus 2. That's what I'm going to multiply the whole top and bottom by. So I'm going to go, hey, x minus 2 is going to get distributed. And if I multiply the top by that, I multiply the bottom by that, I'm not going to really change this because I'm technically multiplying by 1. X minus 2 over x minus 2 is 1. That's what makes this work. And that's sometimes what confuses people. So once again, if you get confused, please ask for help. I'm always here to help. So, what's it going to equal? Well, in the top, the first part here, in the top, if I distribute it, this is going to knock out this. I'll get left with 3. Plus, because I have a plus sign, I'm going to get 5 times this, because in the second part, it wouldn't cancel. Well, is the top part completely pretty yet? No, this is not pretty because I could clean this up. Once again, like the other problem, I'm running out of room. So I'm going to write it down here. And I'm going to say 3 plus 5x minus 10 because I'm just making it prettier. And then I say, hey, I can put stuff together. I can combine these two. And I could say 5x minus 7. That's what the top part's supposed to look like. Let's see what the bottom part looks like. If I multiply x minus 2 times 1 over x minus 2, I'm going to get these to cancel. I'll get a 1. Plus, I'm going to get a 2. There's nothing going to cancel here, so I'm going to have to get this thing right here. Whoop. Get this right here. And once again, let's make it pretty. Let's clean this up. 1 plus 2x minus 4. I can combine it. I could write 2x minus 3. Now, stop for a second. Don't jump the gun. This guy's a binomial. This guy's a binomial. Do they match exactly? No, they do not. That is your answer. You're done. That's it. You can't go any farther. But you definitely have something that is less complicated than what you started with. And that's the whole point of simplifying. All right, we're getting there. We're getting there. But remember, look, there's some work to be shown to get to this location. Please show that work. Anytime you show me work, it's worth something. Okay, what about this crazy one? Well, see, this guy's a binomial, and this guy's a monomial. That guy's a monomial. Binomials and monomials are not the same. So I can't just say I'm going to multiply everything by x minus 3. Or I'm just going to multiply everything by x. And what's up with this dude? I don't know if you guys see it, but there's a GCF there. I could rewrite the bottom part so it looks like x times x minus 3. That's what I could do. And then I go, you know what? That guy looks like the least common multiple to me. If I want to get rid of the single letter, I got to multiply by x. If I want to get rid of the binomial, I'm going to need that. So sometimes the LCM is a number, sometimes it's a letter, sometimes it's a binomial. It could be any combination of stuff that you need. Now, just to make my work look a little prettier, I am going to erase this part right here. I am. And I'm going to put the x minus 3 part there. I am going to write it so it looks a little cleaner. Because right now, what I'm about to do, I am about to multiply the entire top part and the entire bottom part by the LCM. X minus 3. X minus 3. Now when I do it up here, I got to distribute it because there's two pieces. On the bottom, guess what? Kabam, kabizzle, kaboom. All that stuff goes away, and what do I end up with on the bottom? 4. That's sweet. On the top part, what's going to happen? The first part, these guys are going to go away, and I'll get a 2 times x. That's 2x. Plus, in this part, the x would cancel, and I'd get 7 times x minus 3. Well, you're not done yet because you can make this prettier. You could distribute. So in the top, I'd end up with, and once again, I'm going to run out of room. I'm going to move it down here. But in the top, I'd end up with 2x plus 7x minus 21 over 4. And let's pretty it up because I could put 2x and 7x together, and I'm going to write 9x minus 21 over 4. Beautiful answer. I can't do any reducing. I am done. But if you really wanted to, you could say, you know what? 3 goes into 9. 3 goes into 20. So this is one of those problems where in the answer key, if you wanted to, you could write it like this. This is correct. So is that. If factoring a GCF out does not help you reduce something, you don't technically have to do it. They're both legit. That's fine, and that's fine. They're both correct. So once again, when you guys go through the problems, double check. Check your answers. Okay, now what about this guy? The LCM. It could be a number, it could be a letter, it could be a binomial, but I'm going to give you a big hint. The least common multiple is never the teeniest dude. See, if you have an x to the first and an x to the second wins. If you had an x to the 11th and x to the 12th, x to the 12th would win. When it comes to the least common multiple, go big or go home. So I'm going to take the whole top part here, whole top, and the whole bottom, and I'm going to multiply by x squared. Over here, I'm going to multiply by x squared, because if I multiply top and bottom by the same thing, I'm not really changing it, I'm just rearranging it. I know that's a fresh rhyme. Word. So I'm going to multiply the first guy by x squared. What happens? This one takes out one of those. I get 5 times x. Plus, this guy takes out this guy completely. I get a 3. Well, heck, I'm done. That's as pretty as that's going to get. On the bottom, when I multiply here, I'm going to get this guy to knock out this guy completely. What do I get left with? 1. minus, and then one of these takes out one of those, so I get left with this. And that is a fine answer. That's beautiful. But it's not polite. Okay, I just want to talk one little thing about politeness. In mathematics, we have a certain way to organize our work so that whoever picks up our work is not confused. So one of the rules that we like to follow is letters go first, numbers go last. So if I were to reorganize that, I could write it like that. This would be polite. This I'd still give you full credit on the test, but when you go to check your answers, I'm going to put them in the polite format. So you might go, why is my answer backwards? Well, because I'm being polite. Letters are cooler than numbers. Okay, that's the rule. So if you go through the practice problems now, you're going to see one like this. And this is my last example. Because this one, well, I got a 2x, I got an x, I got a 4x, I got a 4. This is one of those where the LCM for the problem is part letter and part number. See, the LCM can change depending on the situation. And do keep in mind, 1, 2, 3, 4, 5 fraction bars. So as soon as I count and I see 4 or more, I know I'm going to start taking this strategy, not the other one. So I'm going to bring it in, and I know I'm going to run out of room here, but let's do the top part first. See, I have a 2, and I have a 4, and I have a 4. What is the least common multiple just for the numbers? It's a 4. But I got an X, I got an X, I got an X. You got to use an X then to get rid of that guy. But let's see how this shakes out. Okay, I'm going to go back to my red pen. 2 would go into 4 twice. X would knock out X. So in the first one, I'd get a 2 left over. But I have to multiply it by this. Plus, this X is going to knock out that X. So I'd get 4 times 4 for the second part. And that's 16. I would still need to make it pretty. The top part is not done yet. So here we go. I'm running out of room, going down here. And I'm going to say that's 2x plus 6 plus 16 more. And I could combine the 6 and the 16, and I'd get 2x plus 22. And I'm going to stop right there and see what happens in the bottom. In the bottom, this whole chunk would knock out that whole chunk. I'd get left with 1 times 5. That's 5. Plus, well, in the second part, when I distribute it, 4 would knock out the 4. I'd get 3 times x. That's 3x. Well, hey, I could write it like 5 plus 3x. I could. But being more polite would be put the x part first and the number part second. And that's a beautiful answer. You're done. A double fraction is always, in mathematics, considered not simplest form. Because any double fraction, no matter what it is, can be rewritten as a single fraction. It totally can. And there's my single fraction. In fact, sometimes you get lucky and everything cancels. You get just like a regular answer. My answer's 2. Something like that. So anyway, I've gone through every type of problem you're going to see. Type 1 style, type 2 style. Let's look at the practice, because here's the practice. Ba-boom, ba-boom, all the way at the top here. I hit it from view. Complex rational expressions. Simplify each. So there's problem 1. See problem 1? That's type 1 or type 2? What kind is it? It's type 1. Don't do it the way we just talked about. But this guy is a type 2. Hey, do it the way we just discussed. How about number 5? Number 5 has 1, 2, 3, 4 fraction bars. I would say he's a type 2. But let's jump down here to 11. And then I'm going to stop marking up this page. Type 1 or type 2 for number 11? I think it's type 1. So I would just simply rewrite this as 6x over x minus 4 divided by that guy. And then I would factor stuff and cancel stuff. So there's 11 questions, but wait, there's more. Here's the next 4 problems. So there's 15 questions total. There are 15 questions total. And I did this one just to see if anybody would get it, because it's got double letters in it. I don't want you to freak out. Double letters. But see if you can get it. If you do, here's your answer key. Here is your answer key. So you can see that when there's 2 different ways to write an answer, I wrote them both. Doesn't matter to me. Take a picture of it. Check your answers as you go through. Make sure you're matching up with me. And if you need help, please ask for help. I'll be there to help you. All right. That's it.